Alrighty, here we go. So it's Tuesday, and we are on section 4.2. So yesterday we talked about how to write an equation in slope-intercept form when I give you the slope and the y-intercept. So I'll just take a look at one right here. It says m equals 1, b equals 5. Y equals mx plus b. That's slope-intercept form. I tell you the slope, I tell you the y-intercept, you write the equation. Pretty simple. All the ones yesterday had that information. I just straight up gave it. A little different today. So now we're going to write the equation of a line when you're given a slope and a point on the line, not the y-intercept. I'm not going to give you the y-intercept today. You are just going to be given a point and a slope. So how do we do that? Well, we have another formula for that. Write this down in your notes. So, linear equation written in this form, this is called point-slope form. So, the one we did yesterday was called slope-intercept form. This is called point-slope form. Basically, they're named for the information you're given. What are you going to be given? You're going to be given a slope, or you'll have to figure it out, we'll talk about it. And you're going to be given a point. So here, the slope, we know how to find slope. You subtract the y's, you subtract the x's. You're going to be given a point. When you substitute on these problems, you only substitute into the ones that have the sub 1s. Very important. You don't ever substitute for this x or this y in these forms. All right? So, what does it look like? Well, write an equation in point-slope form passes through, so the point is negative 8, 3, and the slope, it says, is 1/4. So we start with our form. Y minus y1, m, x minus x1. Plug in your values. Well, remember, all coordinates are written x, comma, y. So that makes this x1 and y1. When we substitute here, we grab these numbers here. So, y minus 3, y1 equals, the slope is 1/4, x minus negative 8. Now, as you do a couple of these, you'll hopefully recognize really, really important on signs here. Remember, minus negative 8 is going to turn into positive. So, let's clean this up a little bit. I see a number in front of parentheses. What am I going to do? Distribute. So this becomes 1/4 x. Minus minus is plus. Get out a calculator if you don't know. 1/4 times 8 is 2. So, now, I'm still trying to write it in y equals form. All right? Not sure why I put that parentheses there. That should be there. So I got to get the y by itself. There you go. Take the point I give you, plug it into the formula. Take the slope, plug it into the formula. Distribute, watch your signs, and then get y by itself to finish the problem. All right? So, let's do it again. Let's do this one. So in case you can't read it, it's 3, negative 1, and the slope is negative 2. When you do this, especially in the beginning, write the formula down so you kind of get the hang of it. All right? Plug in the numbers. Y minus y1. So I got negative 1 here. Plug in negative 1, it turns into plus 1. Equals slope, negative 2. X minus 3. Step 2, distribute. get y by itself. Subtract 1 to do that. Done. That's the basic idea right there. So, sorry, wrong button. What happens if I don't give you all that information? Well, sometimes I'll give you a graph. I still need two pieces of information. I need a slope and I need a point. Well, I've got points, I've got two of them. In case you can't read, this is 1, 2, and 3, -2. I've got points, I've got two of them. How can I find the slope? Well, you either count down, right, or you go to the formula. All right? Since I have the graph, I'm going to count. That's going to go a lot faster. 1, 2, 3, 4, down 4, 1, 2, right 2. So the slope is -4 over 2 is -2. Go back to my formula. Plug it in. Well, which one do I plug in? I have the slope is -2. Which point do I use? The nice part is it doesn't matter. You can use either one. I'm going to grab this one just because they're both positives and I don't have to mess with the negative. So y minus 2, the slope is -2, x minus 1. Again, that information came from the point on the graph. The slope I had to figure out by counting. Then we do the same steps. Distribute. Add 2 to both sides. And I'm done. Same steps. I needed to do a little bit more work to find the slope here, but it's the same basic idea once I have the information. All right, what if I don't give you a graph? Fair enough. What if I give you 2 points? Remember, function notation is just telling me coordinates. This is 4, -2. This is 8, 4. I have 2 points. I need a slope. How do I find the slope? Lucky for us, we have an equation for that. Slope formula, no big deal. Plug them in. Second one minus the first one. Watch your signs. Second one minus the first one. 4 plus 2 is 6. 8 minus 4 is 4, so this is 3 over 2 is my slope. Perfect. Pick a point. It does not matter which one you pick. I'm going with the second one so I don't have to mess with negatives. Y minus 4, the slope I calculated. X minus 8. Step 1, distribute. If you're not good with fractions, that's pretty easy. Get out a calculator and plug it in. If you are good with fractions, you should be able to come up with 12. And then we get y by itself to finish the problem. Add 4 to both sides. Finish. Questions, comments, issues? Hit me up if you got them. So, if I give you points, you use the slope formula. Give you points, use the slope formula. If I give you points in function notation, those are just coordinate points, use the slope formula. All right, you kind of get the hint here. We're going to be doing that a lot. Last one, I could give you a chart, word problems, everybody's favorite. Says you pay an installation fee and a monthly fee for internet service. The table shows you the cost for different numbers of months. Can the situation be modeled by a linear equation? So whenever you see linear equation and linear model, they want you to write an equation, okay? They want you to write an equation of the line. That represents the total cost of the function of number of months. So first off, if I'm going to write this, remember what we've been doing about charts. These are just points on a graph. These are coordinates. 3, 176, 6, 302, 9, 428. They're just coordinates. So think about this as having 2 coordinates. Can I find a slope? Sure. So y minus y over x minus x. 302 minus 176 over 6 minus 3. I'm going to grab a calculator. This one's kind of big. So this is 126 over 3. Divide that, I get 42. That's my slope. Okay? Now the first question is, can this situation be modeled by a linear equation? So the first question is this linear? Well, going back to chapter 3, the first section, second section maybe, we talked about is something linear. If it's linear, it has to have a constant slope. It's got to have a constant rate of change. So I need to check and see if it's the same slope here. So if I go 428 minus 302, I get the same thing. 3 months, divide by 3 for these 3 months, I get 42. Check it out again. Is it constant? 554 minus 428. Same thing. So I know that the first question is this linear? Yes, because I checked and all of these come out to be the same. So now, can I write a linear model? Sure. Do the same thing we've been doing. Minus y1 equals slope x minus x1. And finish the problem. Now, it's an equation. So what does this mean? Well, I know it's 42, and since I can look at this problem, this is the number of months, this is total dollars, it's going up by 42. That means this is $42 per month. Well, what's this? This is my installation fee. It's the initial $50 you pay to sign up and have them come give you the materials, and then it's 42 months for every month after that. So I can take the information they give me, check to see if it's linear, see if the constant rate of change is there. If it is, it's linear, and I can write an equation. All the numbers on the chart is just x's and y's, and then I can interpret the equation I made based on the word problem. All right. Good luck. Ask questions. You know the drill.